A very good morning, students. Today we'll be dealing about the currents of Pacific and Indian Ocean in oceanography. Ocean water is on the move, affecting your climate, your local ecosystem and the seafood that you eat. Ocean currents, abiotic features of the environment, are continuous and directed movements of ocean water. These currents are on the ocean surface and in its depths, flowing both locally and globally. In today's lesson, we'll learn about the prominent currents of the Pacific and Indian Ocean. Pacific Ocean currents. North Equatorial Current, which is warm in nature. The North Equatorial Current originates off the western coast of Mexico and flows in the westerly direction and reaches the Philippines coast after covering a distance of 7,500 nautical miles. This current is originated because of the Californian current and the northeast monsoon. The volume of water continuously increases westward because numerous minor branches join this current from the north. It is significant to note that North Equatorial Current flows as a continuous current in the North Pacific Ocean, but there are seasonal variations in its northern and southern marginal areas. Next current, South Equatorial Current, which is again warm in nature. The South Equatorial Current is originated due to the influence of southeast trade winds and flows from east to west. This current is stronger than the North Equatorial Current. Numerous minor currents join this current from the left and thus the volume of the water continuously increases westward. The current is bifurcated into northern and southern branches near New Guinea. The northern branch turns eastward and flows as counter-equatorial current, while the southern branch moves towards the northern and northeastern coast of Australia. Counter-equatorial current, which is again warm in nature. The current flowing west to east between the north and the south equatorial currents is termed as the counter-equatorial current. Because of the trade winds, immense volume of water is piled up in the western marginal parts of the ocean. With the result, there is general slope gradient of water surface from the west to east. Between the north and the south equatorial currents, the counter-equatorial current continues to flow from the west to the east in a fully developed form throughout the year. It is interesting to learn that the counter current lies always in the northern hemisphere but further away from the equator in the northern summer. According to Montgomery and Palmin, the counter current is maintained by the piling up of the light and the warm surface water against the western boundary of the ocean. The counter current is characterized by the descending motion of the water at its southern boundary and ascending motion at the northern boundary. Owing to the convergence and the divergence, this current does not flow due east or due west. On its surface is found a spiral motion which carries water from the northern to the southern boundary of the counter current at the surface. It also carries water in the opposite direction at depths between 50 and 200 kilometers. In the equatorial region on the Pacific Ocean, there is a subsurface current moving east beneath the south equatorial current at the equator. Kuroshio system, which is again warm in nature. The Kuroshio system comprises several currents and drifts is similar to the Gulf Stream system of the Atlantic Ocean. The system runs from Taiwan to the Bering Strait and consists of Kuroshio current, the Kuroshio extension, the North Pacific drift, the Tsushima current and the counter Kuroshio current. Kuroshio current. The North Equatorial Current turns northward due to the obstruction of the Philippines and thus gives birth to the Kuroshio current, which flows from Taiwan to Ryukyu Ridge at 30° north latitude. Kuroshio extension. The Kuroshio current leaves Japanese coast and turns eastward near 35° north latitude under the influence of the westerlies and is bifurcated into two branches. One branch moves easterly direction while the second branch moves in the northeast direction up to 42° north latitude and thereafter it also turns eastward. The northern branch ultimately merges with the cold Oyashio current coming from the north. Next, North Pacific drift. The Kuroshio current is extended further eastward under the influence of the westerlies and reaches the western coast of North America. Just before 150° west longitude, the major part of the current turns southward while the remaining water moves eastward up to Hawaii coast and the western coast of North America. The North Pacific drift is bifurcated into two branches. The northern branch becomes the Aleutian current, while the southern branch gives rise to the Californian cold current. This Aleutian current is further divided into two branches. One branch goes towards the Bering Strait, while the second branch moves towards the Gulf of Alaska. Tsushima current. Near 30° north latitude, one branch separates from the Kuroshio current and enters the Japan Sea and flows along the western coast of Japan in the name of Tsushima current. The warm current with relatively higher temperature and salinity modifies the weather condition of the Japanese coast. Counter Kuroshio current. The Kuroshio system forms a gyral system between the Hawaii Islands and the American coast, and thus the oceanic water moves in a westerly direction in the name of counter Kuroshio current. Oyashio current, which is again cold in nature. The Oyashio cold current is also known as the Kuril cold current. The cold current flows through the Bering Strait in a southerly direction and thus transports cold water of the Arctic Sea into the Pacific Ocean. Near 50° north latitude, this current is bifurcated into two branches. One branch turns eastward and merges with the Aleutian and Kuroshio currents. The second branch moves up to the Japanese coast. The convergence of the cold Oyashio or the Kuril and the warm Kuroshio current causes dense fogs which become potential hazards for navigation. Californian cold current. The Californian current, an example of the cold current, this current is the eastward extended portion of the North Pacific Drift. This current is generated because of the movement of oceanic water along the Californian coast from north to south in order to compensate for the loss of water which is caused due to the large scale transport of water off the coast of Mexico under the influence of the trade winds in the form of north equatorial current. This current, after reaching the Mexican coast, turns westward and merges with the north equatorial current. The main area of upwelling of the cold water lies at 35° and 41° north latitude. In the summer months, a counter current originates at a depth of 200 meters below the surface, which carries enormous quantity of equatorial water towards the north. By the end of the northern summer, numerous eddies form near the coast which carry the coastal water away from the coast. Peru current, which is again the cold current flowing along the western coast of South America from the south to the north, is called the Peru current or the Humboldt current. This current is known as the Peru coastal current near the coast, while it is called the Peru oceanic current off the coast. Mean annual temperature ranges between 14°C and 17°C, and the average velocity of the moving water is 15 nautical miles or 27 kilometers per day. The temperature of the sea water increases from the coast towards the ocean. When this current flows at some distance from the coast, its name is changed as the Peru oceanic current. This current originates in the areas near the Antarctic. The cold water mass of the Antarctic Ocean is carried by the westerlies towards the east, which bends near the west coast of the South America towards the north. Thus, the Peru current comes into existence. On the basis of the observations made by the ship Discovery, it was found that the total transport by this cold current is estimated to be about 10 million to 15 million cubic kilometer per second, which comprises the upper surface water and the intermediate Antarctic water mass. This current is much wider. Near 35° south latitude, the current extends up to 900 kilometers from the coast. Before reaching to the equator, the current deflects towards the west. However, this current flows with a slower speed. Near the northern limit of the current, certain characteristic changes occur due to the changing seasons. In the northern summer, when the wind belts are displaced towards the north, Peru current crosses the equator and converges with the equatorial counter current. But in winter of the northern hemisphere, the equatorial counter current extends southward and starts flowing near the Ecuador coast and joins the Peru current after moving beyond the equator. This warm south flowing current along the coast is called El Nino. El Nino counter current, which is again warm in nature, a subsurface warm water known as El Nino current, flows from north to south between 3° south and 36° south latitudes at a distance of about 180 kilometers from the Peruvian coast. The southward shifting of the counter equatorial warm current during the southern winter gives birth to the El Nino current. The temperature at the Peruvian coast does not fall considerably because of this current. Though the amount of rainfall increases along the coast due to this current, but fishes die due to the disappearance of planktons and occurrence of guano disease and pests caused by El Nino. It may be pointed out that El Nino also affects the monsoons in the Indian Ocean. East Australian current, which is again warm in nature. South equatorial current is bifurcated near the Australian coast into the northern and southern branches. The southern branch flows as East Australian current from the north to the south along the eastern coast of Australia. New Zealand is surrounded by this current. It is deflected eastward near the 40° south latitude due to the deflective force of the earth and flows in the easterly direction under the influence of the westerlies. This is a warm and more consistent current. It raises the temperature of the East Australian coast for considerable distance southward. West wind drift, which is cold in nature. A strong ocean current known as the west wind drift flows from west to east under the influence of the westerlies between Tasmania and the South American coast in the zone of 40 to 50° south latitudes. This current becomes much stronger because of the immense volume of the water mass and high velocity winds called as roaring 40s, and thus the current flows with great velocity. In the far east, the current is bifurcated into two branches. One branch enters the Atlantic Ocean through the Cape Horn, while the second branch turns northward and joins the Peru current. Indian Ocean currents. The circulation current of the Indian Ocean is different from the Pacific and the Atlantic Ocean. The Indian Ocean is surrounded by huge landmass of Eurasia in the north and is only half the ocean. Hence, the circulation in the southern Indian Ocean is similar to the other two oceans, while the circulation in the northern Indian Ocean is completely different. The monsoon winds also play a peculiar role in the reversal of the direction of the currents in the North Indian Ocean. The North Indian Ocean circulation. The currents in the North Indian Ocean are affected by the landmass of Eurasia and the monsoon winds. Hence, there is a change in the direction of the currents from season to season in response to the seasonal rhythm of the monsoons. Firstly, the summer circulation. The north equatorial current and the counter equatorial current is absent in the summer due to the influence of the southwest monsoon and the absence of northeast trade winds. A strong current flows from west to east in the summer season. The southwest monsoon drift originates in the summer, and from June to September the north equatorial current is replaced by an easterly movement of the water. Thus, the circulation of the currents is in a clockwise direction. Somali current is also formed in the summer by the eastward movement of the water caused by the southwest monsoon drift. It flows from the Horn of Africa in the north east of the Africa. It is a cold current, and due to the region of the upwelling, Somali and its neighboring countries are, and thus it flows in the westerly direction. Winter circulation. North equatorial current is formed in the winter under the influence of the northeast trade winds. It originates from the south of Indonesia and flows from east to west towards the south of Sri Lanka. The northeast monsoon drift is also formed in the winter starting from December, when the northeast monsoon causes a westward and southward drift along the eastern coasts of India and along the Arabian coast. This generates an anticyclonic circulation in the Arabian Sea and the Bay of Bengal. The southern Indian Ocean. The circulation in the southern Indian Ocean is continuous, unlike the North Indian Ocean, and is not affected by the change of seasons. The surface circulation in the South Indian Ocean is similar to the counterclockwise circulation observed in the South Pacific and the South Atlantic Oceans. To the south of the equator, the currents are characterized by a greater degree of constancy. In this part of the Indian Ocean, there is no seasonal reversal in the direction of the flow of the ocean currents. However, the following are the major currents of the South Indian Ocean: the South Equatorial Current, the Agulhas Current, and the West Wind Drift, and the West Australian Current. These currents lead to the development of an anticyclonic circulation in the southern part of the Indian Ocean. South Equatorial Current, which is warm in nature. The southeast trade winds originate in the South Equatorial Current. It flows from east to west and is a warm current. The flow of the current is strengthened by the South Pacific Equatorial Current through Indonesia. The South Equatorial Current splits into two branches by the Madagascar Island, the Madagascar Current and the Mozambique Current. These flow along the east of Madagascar and the east of Mozambique, respectively, to converge at the Cape of Agulhas. Henceforth, this current is known as the Agulhas Current. All the three currents are warm currents. The Agulhas Current, joined by the west wind drift or the Antarctic Circumpolar Current, and is deviated to its justified by the landmass of Australia. This flows as the West Australian Current along the west coast of Australia in the northern direction to finally reach the South Equatorial Current, thus completing an anticyclonic circulation in the South Indian Ocean. Since it is formed by the west wind drift, West Australian Current is a cold current. Equatorial countercurrent. At the equator, there is upwelling in the winter due to north and south equatorial currents, and this causes the generation of the equatorial countercurrent. During the summer as well as in the winter months of the southern hemisphere, a branch of the South Equatorial Current deflects towards the south along the east coast of Africa, supplying water to the Agulhas Current. The South Equatorial Current bifurcates into two branches near the Madagascar Current, while the other branch flows towards the south through the Mozambique Current. To the south of the Madagascar, at about 30 degrees south latitude, both these currents join together to create the Agulhas Current. The Agulhas stream, as it is called, is well-defined and narrow current to the south of 30 degrees south latitude. From the coast, its width measures less than 100 kilometers. To the south of Africa, a major part of the Agulhas Current deflects to the south and then towards the east. This current sends some water into the Atlantic Ocean and some into the Indian Ocean through its branches. To the south of the continent, near the Agulhas Cape, the main branch flows towards the east and converges with the west wind drift. Due to the change in the direction of the flow of the main branch, flows towards the east and converges with the west wind drift. Due to change in the direction of the flow of the main current to the south of Africa, a large form of eddies develop there. Thus, a very complicated system of surface currents with seasonal variations is found there. According to Dietrich's measurements, the transport by this current is a little more than 20 million meter cube per second. Thermohaline circulation. The Great Conveyor Belt. The slow circulation of the deep ocean water is caused by the density differences rather than by the wind energy. As we have learnt about, the surface winds are driven by the winds, while the water at the greater depth in the oceans is driven not by the winds but by the differences in the water density. Since density is mainly a function of water, temperature and salinity, the movement of the water due to difference in the density is known as thermal circulation. The word thermohaline is comprised of two parts, thermal, which means heat, and haline, which means salt. The basic circulation pattern comprises deep water and the water being transported towards the Pacific Ocean, where it rises towards the surface and is carried to the downwelling regions in the North Atlantic Ocean and the Weddell Sea. This cycle is very important from the climatic point of view and is known as the conveyor belt. The slow, steady and three-dimensional flow of water in the conveyor belt distributes dissolved gases and solids, mixes nutrients and carries the juvenile stages of different organisms between various ocean basins. In addition, the cycle provides a stabilizing effect on the climate. It may be stated that if it is disturbed in whatsoever ways, it is capable of causing sudden climatic change within a period of few decades. Conveyor belt is a simplified version of the actual circulation of the ocean. Ocean currents are the continuous, predictable, directional movement of the sea water driven by the gravity, wind, the Coriolis effect and the water density. Ocean water moves in two directions, horizontally and vertically. Horizontal movements are referred to as the currents, while the vertical changes are called the upwellings or the downwellings. This abiotic system is responsible for the transfer of heat variations in the biodiversity and the Earth's climate system. In today's lesson, we have learned about the different currents of the Pacific Ocean and the Indian Ocean. Then we have also learned about the thermohaline circulation.